Hello and welcome to lecture 2 of week 15. This time we're talking about ocean acidification and sea level rise. So we talked last time about the ocean acting as a buffer for the excess heat and the excess carbon dioxide that is coming onto our planet due to what we've been doing, due to the Industrial Revolution. And how the ocean is absorbing most of that heat and a lot of that carbon dioxide. And that causes the ocean to warm up. And that's going to have some major impacts to ecosystems in the ocean, which probably doesn't surprise anyone. Carbon dioxide absorption is going to alter ocean chemistry. We'll talk about what that is in just a few minutes. And sea level rise is affecting coastal communities worldwide. We see that here, in detail. So the heat content is rising rapidly since the 1970s, measured using different satellites and floats in the ocean. Most of that heat is stored in the upper 2,000 meters of the ocean. And we'll look at the data, and the key indicator is a key indicator of long-term planetary warming. So ocean surface temperatures. So this is a graph that just looks at every year from 1979 until 2024, and obviously only until April of 2024. And you can see the average temperatures here in degrees Celsius, and you can see overall they have been rising since 1979. You can see 2024 was the warmest year on record. 2023 was the warmest year on record before that. Obviously, the water in the oceans is getting warmer over time. And you might ask, why does that matter? So there are a few reasons why that matters, but any marine heat wave is an extended period of time where the ocean temperatures are warmer. These events can last weeks to months, and they generally cause some issues for the ocean. They can very dramatically affect marine ecosystems. One well-known example was the Pacific marine heat wave called the Blob, which occurred from 2013 all the way to 2016. And that created a lot of warmer water around the North Pacific and disrupted fisheries, so made fishing very difficult, caused seabird die-offs. A lot of seabirds were dying, and obviously when that's happening, marine food webs are disrupted. Marine heat waves are becoming more common as the temperatures of the ocean are warming. In Hawaii, marine heat waves are closely linked to coral bleaching events. The higher the temperature gets, the more likely those corals are to expel their algae. The symbiotic algae in corals is called zooxanthellae. We'll talk a lot more about this next week. That's essentially our entire focus for next week is coral reefs, corals, and coral bleaching. Bleached corals lose their color, but they also lose that zooxanthellae, which is their energy source. Corals can recover from bleaching, but repeated bleaching reduces the reef's resilience over time. So the more bleaching events that happen, the more severe those events are, the more likely corals are to not recover from bleaching. And if you remember last week, we talked about all these marine sources and the pressures on them and how they're changing the oceans. Well, having different chemicals in the ocean, having all those other factors come in as well, just causes coral reefs to be even that much less resilient over time. We'll look at this again next week, but this is just showing essentially a healthy coral, a stressed coral, and a bleached coral. And you can pause here and read all of it if you'd like to, but what causes coral bleaching in general is increase in temperature, runoff and pollution, and overexposure to sunlight. So if we have more solar radiation than normal, that can cause coral bleaching as well. Extreme low tides can actually cause overexposure to sunlight. So these things all work in conjunction with each other to cause coral bleaching. Now into ocean acidification. We are not going to talk about ocean acidification much at all next week, so we're going to use this week to talk quite a bit about it. So CO2 dissolves into seawater from the atmosphere. It's carbon dioxide dissolves into seawater from the atmosphere, and that reacts with ocean water to form carbonic acid. Now, obviously, if we've got carbonic acid in the water, that's going to make seawater slightly more acidic. The ocean is still basic overall. It's not acidic overall, but it is less basic than it was 100 years ago. That shift toward a lower pH has some consequences. If carbon dioxide is forming carbonic acid, it grabs onto carbonate ions. So carbon dioxide is grabbing onto carbonate ions to form carbonic acid. Those carbonate ions are needed by many marine organisms to build their shells and skeletons. So anything that has a shell is going to need those carbonate ions to build it. Echinoderms actually use carbonates to build they don't really have a skeleton, but their bony parts. Many organisms, corals too, use carbonate to help build their structures. So those carbonate ions are less and less available because carbon dioxide comes into the water and grabs onto carbonate to form carbonic acid. So not only is the pH declining, that's problematic in and of itself, and the calcifying organisms can't build their shells, and that's going to affect the food web as well. So that's a major issue, a big problem. This graph shows atmospheric CO2 from 58 to 2010 in this case, but this is essentially that same healing curve graph that we saw in lecture 1, along with the seawater carbon dioxide levels and seawater pH. You can see seawater carbon dioxide levels are increasing in correlation with atmospheric CO2 levels, and the pH of the ocean is decreasing as the seawater CO2 levels increase. So you can see the data here clearly, and it's pretty concerning. So that's where we are with that. And we've got a couple of your readings have a lot more about ocean acidification in it, so you can learn a little bit more that way. Sea level rise. So the global sea level is steadily increasing, measured by satellite altimetry. Two main causes: thermal expansion. So as water gets warmer, it gets bigger, which might not sound like a lot. If you're looking at a glass of water, you don't notice that it's bigger. The water itself is bigger in the glass when it's warm than when it's cool. But when you look at as much water as is in the ocean, that makes a much bigger difference. And the second cause is melting ice. So glaciers, sea ice sheets, glaciers, icebergs, things like that melting is also causing the rise in sea level. Scientists have been monitoring it very closely since the early 90s, and data is showing an upward trend and an accelerating upward trend in recent decades. So here we can see this is just from 1992, and this NOAA graph tells us which satellites they use to measure it. And you can see there's always overlap here between the different satellites, which is interesting. So we started with the TOPEX, then JASON 1, JASON 2, JASON 3 satellites to measure the global mean sea level. And you can see that change over time trending upward as we continue on here. So again, why does that matter? So here in Hawaii specifically, sea level rise definitely causes higher coastal flooding risk. Any storm that we have is more likely to cause major flooding the higher the sea level is. Accelerated shoreline erosion. All of our shorelines are already fairly susceptible to erosion. If we have sea level rise, they're even more susceptible to erosion. Saltwater intrusion into freshwater aquifers. That is obviously a major issue. We have a very limited supply of fresh water on this island. I say that. It rains a lot over in Hilo, but we, especially for our aquifers on the west side, we they're limited. And if they get salt water, if they get contaminated with salt water, that is a major issue. And of course, threats to infrastructure like people's houses, businesses, things like that, ecosystems, and even beaches can be impacted by sea level rise. So, what are some of the stressors on marine ecosystems? That warming water alters species distributions. Um, Acidification weakens the shells and the coral skeletons. Marine heat waves damage reefs and fisheries. And as we've said before, the marine ecosystems are really resilient when they are affected by one stressor at a time. But unfortunately, that's rarely the case. Climate change introduces many overlapping stressors and pressures at once, and these interact, which makes it much more difficult for the ecosystems to recover and be resilient. So that's the biggest issue here, is that sea level rise, acidification, and heat waves work together to cause even more damage to our ecosystems. So the key takeaways from this one: ocean warming is accelerating, which is causing more marine heat waves, more coral bleaching, increases in those events. Ocean chemistry is changing. This carbon dioxide level is coming up, which is increasing the amount of carbonic acid in the ocean. And sea level rise is coming up exponentially, and that poses many, many risks to the coasts around the world. In the third and final lecture for week 15, we're going to look more about Hawaii, the what's happening in Hawaii and the future of the oceans, and how climate change affects us here locally more.